If you haven't watched it yet, please start by watching the YouTube video that I linked as a demonstration. I usually do this during class, but I can't this year because I won't see you live for this lesson. So I hope that you already watched that quick little YouTube video. All right, that introduced you to some of the definitions, but I do want to go over some of them quickly. So an ellipse is the set of all points P in a plane such that the sum of the distances from P to two fixed points, F and F1 and F2, is a constant. And the focus of an ellipse is one of those two fixed points. So let's summarize so far. A circle is all the points equidistant from one point. And we call that point the center. A parabola is all the points equidistant from a line and a point not on that line. But an ellipse is a little bit different. It's all the points where if you go from the point to the curve and back to the other point, the sum of those two distances is always the same. So I'm going to write that out and then come back and explain it. So an ellipse is the shape that's created when the sum of the distance from a focus to the curve and back to the other focus is what's constant. So it's not equidistant from the 2 points, it's that the sum of those two things is always the same. So basically, if I have an ellipse and I have the two foci, foci is one of the ways that you can pronounce focus in plural. The other is foci, both are okay. So if I start at the first focus and I go to some point on the ellipse, and then I go to the other focus, the sum of those two segments is the same as if I pick some other point and go focus to the point and back to the other focus. So no matter which point I pick on the circle, if I start at a focus, I'm sorry, not the focus, the ellipse. If I start at the focus and I go to the ellipse and then back to the other focus, that distance is always the same anywhere within the same ellipse. So it's a little bit of a different definition. Because because ellipses are not the same all the way around, they don't just have a diameter like a circle does. They have a major axis and a minor axis. And thankfully, it kind of makes sense. The major axis is the long one, and the minor axis is the short one. The major axis is always the one that contains the two foci for the ellipse. And so you can see a couple of good images there where all the parts are labeled. Now you're going to notice some A's and some B's. So A is going to be the distance from the center of the ellipse out to one of the vertices, whereas B is going to be the distance from the center of an ellipse out to one of the co-vertices, which means the end of the minor axis instead of the major axis. So instead of having a single diameter that's the same everywhere, you have a major axis, which is the longest distance across an ellipse, and that would be A to the right and A to the left, so a total of 2A in length. And then you have the shortest distance across an ellipse, which goes in the perpendicular direction, goes along the minor axis. It'll have a length of 2B. Now, you have a lot of formulas here in the middle because this is a little bit more complex than your basic circle, even though all an ellipse is a bit of a squashed circle. So a horizontal ellipse and a vertical ellipse you can tell them apart in their equations because A and B will be in opposite locations. Now remember, A is half the major axis and B is half the minor axis. So whichever number is bigger, that's how you're going to know that it's A versus B, right? A always has to be bigger than B. So in a horizontal ellipse, notice the bigger value is going to be under the x, whereas in a vertical ellipse, the bigger value will be under the y. And that's how you can tell quickly by looking at an equation which is which. All right, Let's try some problems. The first one says, what is an equation in standard form of an ellipse centered at the origin with a vertex at 8, 0 and a co-vertex at 0, 5? Just like we did with other shapes, it really helps if you start by making a sketch. So if I put my axes in and they tell me that my vertex is at 8, 0, I now know that negative 8, 0 is the other end of my major axis, whereas my co-vertex is at 0, 5. So 0, negative 5 is the other end of my minor axis. So my ellipse looks something like this. We're asked to come up with an equation in standard form for this ellipse. So I know that I'm going to have an x squared over something plus a y squared over something, and it's going to equal 1 because that's the way the formula is set up for a horizontal ellipse. For a vertical ellipse, it's almost set up exactly the same. The only difference is whether the a comes first or the a comes second. So since this is a horizontal ellipse, the longer distance needs to be under x because that's the horizontal direction. So my a value is 8. So a squared is 64. So 64 is what is the denominator for x squared. My b value is 5. So b squared is 25. So that's the denominator for y squared. And that's all it takes to come up with this equation. In number 2, we're asked what are the foci of the ellipse with the equation 4x squared plus 36y squared equals 144. And sometimes at first glance, this really throws students a little bit because it's kind of a wacky looking equation. And it doesn't look anything like the standard form that we were just looking at above. So here's the key. Ellipse equations are always set equal to 1. This is set equal to 144. So if I want it to be set equal to 1, I have to divide both sides by whatever that constant is on the right-hand side. And then I can reduce my fractions. So clearly on the right, we're going to have 1, which was our goal. Well, I now need to take and reduce the other two fractions so that it'll be written in the normal form. So if we reduce the first fraction, we're going to get x squared over 36 because 144 divided by 4 is 36. Plus, if we reduce the second fraction, we're going to get y squared over 4 because 144 divided by 36 is 4. So now we have the equation in standard form. Okay, this is going to help us figure out how to graph, but we're also asked to find the foci. And remember, the focal length is always c, no matter what type of shape we're looking at. In a parabola, the focal length was c. That was the distance from the vertex to the focus. And in an ellipse, the focal length is also c. So that's going to be the distance from the center of the ellipse out to either of the foci. So there's a handy little formula given in the tables up above. So if we look up here, oh, no, actually it's not given in the tables up above. I thought it was written on the form. Okay, well, I will have to give it to you. Conveniently, it's basically the Pythagorean theorem, just with a little twist. So the formula that we're going to need is c squared equals a squared minus b squared. This is the formula that gives us the relationship between half of the major axis, half of the minor axis, and the length of the focus. So we can see right in the formula that a squared is 36 minus b squared, which is 4. And we can see that that total is 32. So c squared is equal to 32. But c, the focal length, is the square root of that. So we need to take the square root of each side. And the focal length is the square root of 32, or 4 root 2. Of course, this can go both to the right and to the left, but we're simply focused on what's that actual length. So first of all, let's look at the foci. We have to find those two coordinates. Since this ellipse is centered at the origin, and since the larger number is underneath x, we know it's horizontal. So I know I'm centered at the origin, and I know it's a horizontal ellipse, so my foci are here and here. Well, this distance, the focal length, is equal to 4 root 2. So that means that this point has coordinates 4 root 2 comma 0. And this one over here is negative 4 root 2 comma 0. So I'm going to make sure that I label those on the graph when I do it. But to answer the question, I just want to list this, and I want to write it as with as little work as possible. So it's perfectly acceptable to say plus or minus 4 root 2 comma 0, so that you're writing the coordinates of both foci at the same time. If you prefer, you can, of course, list them both out separately. Now we're going to go ahead and draw our ellipse. Since we're going to focus on ellipses that are centered at the origin, we're always going to be safe for today to put the axes right in the middle of the graph. Now, if the a squared value is 36, then the a value is 6. So to one side, we need to go 6 spaces, but then to the other side, we also need to go 6 spaces. So we have the vertices at negative 6, 0 and positive 6, 0. Similarly, if b squared is 4, then b must be 2. So we can go up 2 and down 2 to get 0, negative 2 and 0, positive 2 as our co-vertices. From there, we want to draw in 1/4 at a time what this ellipse looks like, making sure that it does look rounded and not like a football. It can be hard to draw it really smooth. Just do the best you can. And as long as it doesn't look pointy at the ends, it'll generally be considered acceptable. So we've got our graph of the ellipse, as well as having identified the foci. It would be good to try to at least approximate where the foci are on the graph. So if I'm thinking back to the form of it as square root of 32, that's between the square root of 25 and the square root of 36. And it's closer to the square root of 36. So this is going to be in between 5 and 6. The foci of this ellipse are very close to the ends because it's so narrow. Let's look at number 3. Number 3 says many road racing tracks in the U.S. are oval with an asphalt surface in the shape of an ellipse or a flattened ellipse around a grassy infield. If an elliptical track has a major axis of 3,400 feet and a minor axis of 1,600 feet, how far apart are the foci? Now, similar to the flashlight problem that we talked about the other day, we can be looking at this track from any angle we want. And most people find looking at an ellipse in its horizontal setup to be less confusing than looking at it vertically. So let's go with that. We're being told that the distance along the major axis is 3,400 feet. So that would be equal to 2a. So therefore, we know that A is equal to half that, or 1,700 feet. That would be the distance from the center out to one vertex. Now we're told that the minor axis has a length of 1,600 feet. So that would be 2B. Therefore, B is 800 feet. The distance from the center to one side would be 800 feet. We're asked to find out how far apart the foci are. So the foci would be like approximately here and approximately there. And our question is, how far apart are they? Well, we can use our formula. C squared equals A squared minus B squared. Well, A squared is 1,700 squared, and B squared is going to be 800 squared. And that might be one that you want a calculator for, but you can also break it down. 17 squared is 189. So this is going to be 18,900. And 8 squared is 64. So this will be, actually I need 2 more zeros on there. Sorry about that. And this will be 640,000 because I'm going to need 4 zeros there. So when we subtract and then take their square root, oh, actually I just caught myself in a mistake. It's 289, not 189. We can see that we're going to need to take the square root of 2,250,000, which is just 1,500. So that's just C, but the distance from one focus to the other would be 2C. So the foci are 3,000 feet apart. All right, our last question on this note sheet is to try to write an equation in standard form for the given ellipse. We always want to look and see what information we have. We can see from the graph that we're given the vertices and the foci. So from the graph, we can see that A is 5 and C is 2. But we need B in order to write our equation. So first we're going to start by using this information. If C squared equals A squared minus B squared, we know that C squared is 4 and A squared is 25. If we were to add B squared and subtract 4 from each side, we would have that B squared equals 21. Now, we actually don't care what B is because B squared is what goes into the formula. But notice this is a vertical ellipse. So although the x squared and the y squared and the 1 never change in the equation for an ellipse centered at the origin, the bigger value always goes under the variable, which is the direction of the major axis. So the b squared, the 21, is going to come under the x squared, whereas the 25 is going to go under the y squared because that's the vertical distance. You should now be ready to do your daily practice for lesson 3.